Hello students, this is Attri. Today we will discuss another topic of class 10th, scattering of light. So students, what is the scattering of light? And the scientist that discovered or that explained scattering of light. We will discuss all these things by some logics. So students, two scientists mainly are explained scattering of light with some logics are. One is C.V. Raman and other is Rayleigh scattering. C.V. Raman that gives a effect named as Tyndall effect, and Rayleigh scattering. Rayleigh is a scientist named due to its special difference created by Rayleigh in scattering phenomena, that is elastic scattering and inelastic scattering. Elastic scattering and inelastic scattering, how they will differentiate. Let us clear all these facts related to scattering, elastic and inelastic scattering. So students, first of all, we have to clear what is scattering. Scattering of light are simple interplay of light by some particles of our atmosphere that does not changes the wavelength of light. So students, it is very clearly noted by you that scattering is a phenomena of interplay of light interplay of light by particles of our atmosphere without changing their wavelengths. Without changing their wavelengths. So students, this is a definition, a practical definition of a very simple definition of scattering. Now, Tyndall effect, what does Tyndall effect signifies? Tyndall effect explains scattering by colloidal particles. Now, what are the colloidal particles? Particle of dust, particle of or air molecules, or particle of smoke, particle of tiny water droplets. These all are, we can say that, colloidal particles. So students, Tyndall effect, this effect describe scattering of light by colloidal particles. Now colloidal particles like air molecule, dust molecule, smoke molecule, or tiny water droplets. These are the colloidal particles. As you know, our atmosphere is a heterogeneous mixture of all the particles. Heterogeneous means that does not mixable clearly. So this is the definition of scattering. This is C.V. Raman, Tyndall effect, and relay scattering. Now relay scattering, what does relay scattering means, and on the basis of which the practical application that follows day-to-day life, that are red color of sun during sunrise and sunset, color of clouds are white, color of sky is blue, color of water in deep sea. These all are explained by relay scattering. Elastic scattering, if the size of colloidal particle is smaller than wavelength of incident light, then it is called elastic scattering. It is called elastic scattering. And students, also the elastic scattering is also called colorful scattering, because all colorful effects of scattering is explained by elastic scattering only. It can be called colorful scattering. In this mathematical relation, intensity divided by lambda k to the power 4, we have to study this relation also, that intensity of scattered light, the light that splits, the light that scatters, always depend on reciprocal of their wavelength. Means to say that violet color in our spectrum means vibgyor. These are the two extreme colors, violet and red. Violet have larger wavelength and red have larger wavelength and violet have lesser wavelength. These two colors, as wavelength increases, intensity decreases. Which type of intensity decreases? Intensity to scatter. अच्छा, स्कैटर को हम अगर हिंदी में बोले, स्कैटर का मतलब होता है बिखरना. सो स्टूडेंट्स, बिखरने की कैपेबिलिटी कम होना, इंटेंसिटी ऑफ स्कैटर कम होना, किसकी? रेड की. इसी के ब्रैकेट के अंदर हम लिखेंगे वॉयलेट कलर scatters more as compared to red. Similarly, inelastic scattering. What is inelastic scattering now? Inelastic scattering is the scattering if size of colloidal particle is very larger than the wavelength of light incident. As we know, clouds seems to be white. Clouds seems to be white just because of it is a result of inelastic scattering. In inelastic scattering, light after scattering, the emergent ray or reflected ray have the same intensity, same wavelength as the light incident on it. So in elastic scattering, the size of colloidal particle is very greater than wavelength of incident radiation. This is non-color scattering. That, for example, this is a colorful scattering and this is a scattering without any color. This is for example, application of inelastic scattering is white color of clouds. Application of elastic scattering is reddish color of sun during sunrise and sunset, and also blue color of sky. These phenomena was explained also in my next videos. So students, in this video only this the scattering effect was briefly explained. If you have any doubt, then please put it on your comments section. Thanks for watching. Thank you.